Find the equation of the normal to the curve x to the 4 minus 2x squared y plus y squared equals 4 at the point 1, 3. So I've got the summary of the question here. So let's have a look at this then. So let's differentiate to get dy dx. When we get dy dx at 1, 3, then we can have the gradient of the tangent, and then we can find out the gradient of the normal, and then we should be able to write down the equation of the normal, shouldn't we? So let's do that then. Differentiate this function, it's implicit. So we use implicit differentiation. So run along the road term by term then. So here, this differentiates to 4x cubed. This is a product here, so it's minus. I'm going to put the minus 2 at the front, I think, yeah, and then put a bracket. So it's, I'll treat this as my u. u dv dx, x squared dy dx, plus v, which is y, times du dx, which is going to be 2x, plus, and now differentiate this, the 2 comes down, 2 to the of the something to the power 1 multiplied by the something differentiated using the function of a function rule, and the constant differentiates to 0. So this implies then, so let's move, we got dy dx, so let's put that here, and let's collect those terms. We're going to have 2y, then we're going to have minus 2x squared, aren't we? Bracket equals, and put the other stuff on the other side, so that's that term and that term. The other terms that we put on the other side, move the 4x over to minus 4x cubed, and then move minus 2y, minus 2 times 2 is 4, 4xy with a minus, move it over, it becomes a plus, 4xy. So that tells us then what dy dx is then. Now take a 2 out from this and write it the second term first and the first term second. So we're going to have a 2, or take a 4 out rather. So we're going to have a 4, x, y minus x cubed. Oh, we could take an x out as well, sorry. So let's do that, why not? So it would be 4x, y minus x squared. That's what we got on top. Move this from times down to divide the other side. Take a 2 out at the same time, and it's y minus x squared. So this is equal to, then these will cancel, and we'll just simply be left with 2x. So at x equals 1 then, dy dx is equal to 2 times 1 is 2. So the normal gradient then, or the gradient of the normal, we know is going to equal minus a half, because that times 2 will give minus 1. So there's our normal gradient then. And so putting in the 0.13, so that implies the equation of the normal then is y minus 3 is equal to the gradient of the normal minus a half, lots of x minus 1, which we've got there. So that tells us then, let's just tidy it up, y is equal to minus a half x, let's expand the bracket while we're at it, plus a half plus 3 is 3.5, which we can write as 7 over 2. So there's the equation of the normal at the point 1, 3.